Okay, I think I'm live. Let's wait. Just a moment, guys. Yeah, we are live now. So, hello everyone. Welcome back again to our channel Coders Arcade. This is Saurabh, and today I am again back with a Java DSA live session. Okay, and today is 4th of June. Okay, my 4 looks like 9, so let me just correct it. So here it is, 4th of June 2025. Okay, till now guys, we have covered a lot of algos, we have covered a lot of searching algos, and I have also showed you given you an idea of how binary search can be used to apply to some questions. Okay, and yes, I hope you have liked it. Obviously, thank you for your support, and at the same time guys, if you really like the content that we are bringing, make sure that you are subscribing to our channel and also hitting the bell icon so that you get notified about the latest updates. Okay, so today, as discussed, what we will do is we will talk about selection sort. Already I have explained in the playlist. You can go and see the live video if you want. Okay, selection. Now I will just ask you one thing. Many people get confused about this. Even today, while I went to the college, I have asked the same question to the students. Okay, same thing happened. Selection versus insertion. See, this we will discuss today. My point is very simple. Both of them have the time complexity of big O of n square. But how do you differentiate them then? What is the different idea behind both of them? Okay, that we need to understand. What is the keyword that you can remember to make it easy to say that this is using selection sort and the other one is using insertion sort? Can anyone tell me what happens? I'm just waiting for you. Okay, let me also open the same thing in my phone so that I can actually, okay, fine. Yeah, I have also opened, and if there are any comments I can actually see them here in my mobile itself. Okay, right now there are no comments, all good. Okay, so as I said, welcome back everyone. So today, as I said, we'll be discussing the difference between these two, and also after that we'll be going to a very important algo, that is quicksort. Okay, this is the time complexity of quicksort is similar to merge sort, but there is certain difference that we have to understand. Okay, we'll do that today. So before that, let's try to understand about the differences between selection and insertion. Okay, very simple guys, please try to remember. There are two keywords that you have to remember. The first keyword, in selection sort we do swapping. In case of insertion sort, we don't do swapping, we do shifting. So if you can remember these two keywords, swap and shift, it will be very easy. So just remember selection, swapping, insertion, shifting. How, I will talk about that now. Okay, so let's go and try to understand them. Let's take both examples. Okay, so here I am writing selection sort. Here I am writing insertion sort. Okay, let's take arrays to understand. Okay, one, two, three, four, five, six, and let's take 1, 2, 3, 4, 5, and 6. I will take the same array only. Say here it is 5, 2, 1, 0, 4, 8. Okay, something like this. Here also let's take something like that only. 5, 2, 1. This I said is 0. Okay, so let it be 0, and this is 4, and this is 8. Okay, and let us drag it to a little bit on that side, because if I am standing here I think you won't be able to see this side. Okay, so fine. So let's talk about it. As I said, in selection, I said that we do swap. In case of insertion, we do what? As I said, it is shift. How? Let's talk about this now. In selection sort, listen to me carefully what I say right now. I am saying that in case of selection sort, at each index we presume that the number at that index is the minimum value, but actually we want to place the minimum value at that index. So imagine my I is here, okay, this is 0th index, right? 0, 1, 2, 3, 4 and 5. So at initially I will say my min index is equal to I, okay. So I am saying that initially my min index is this value, 0th index, and at that index I need to place the smallest element in the array. Got it? So how will I do it? I will take j is equal to I plus 1. That means the next element. So ultimately it will be what? I is 0, 0 plus 1, that is 1. So my j variable starts from here till here. So j is equal to I plus 1 till what? The end of the array, till the last. Okay. So what are we doing? We are trying to compare the first element with the rest of the array. Got it? We are trying to compare the first element with the rest of the array, because at this index I want to place the minimum value always. At each index we will be doing the same thing. So let me just go back. Okay, fine. Now let's try to understand that. So see, I have considered my min index is I, but if you see traverse this area, then you will see that my smallest value is 0. So now my this presumption is wrong, this is wrong. So what I will do, I will just say my min index, what I presumed earlier, is not correct, so this becomes j. Now I need to swap them. See, I told swap, now they will be swapped. Okay. So what will happen to this array? It will become something like this. Try to understand. I will do it here only in the same array only. So this 0 and this 5 will be swapped. So I am just erasing them like this. Okay. So here it will be 0 and this will be 5. See what happened? Got it? That is how it is happening. Now at each index we are placing the smallest element. That is why it is called selection sort. We are selecting a particular index. At that index we are storing the least value of the whole array. Okay. And you can see, because of this iteration, what happened? This part of the array got sorted, and this is a sorted part, this is an unsorted part. There will be similar case happening every time. Every time we will have to sort one less element. Therefore, the number of iterations is n minus 1. That you have to understand. This we have already talked about. I have given this in the YouTube videos only. Okay. That is how it is happening. Now see, second time what will happen? I will take a different color. Okay. We already have this. Let's take orange. Okay. Now I will come here. I comes here, and j will be this part. Okay. So at the second index now, at the index number 1, I will try to place the least element. Now what is the least element? It is actually 1. So now 2 and 1 will be swapped. See how I will do this. See, now 2 and 1 will be swapped actually. So here comes 1 and here comes 2. Make sense? So this is how it is working now. Now my I will move here, and j is here, this part of the array, So 2 is actually at the correct position. So whenever my min index presumption is correct, then I will not do any swapping. If it is not at the correct position, that means when I have selected the index and I see that 2 is at the correct position, 0, 1, 2, absolutely correct, I will not do any swapping. If it is not, then I will do the swapping. Swapping of what? The current value and any least value. Now see for the next one, 5 and 4. See, now I am talking about index 3. At this index I have 5 now, but 5 is not correct because in the less part, in the remaining part of the array there is a smaller element than 5. So, 5 should be swapped, right. So, 4 comes here and 5 goes here like this. See, 4 comes here, 5 goes here. Now it is already sorted. That is how it is working. This is simple idea of selection sort. Select the index, place the least value at that index. That is it. Okay, I hope you have understood this. Any doubts, please let me know. Let me check if there are any comments. Not yet. So, all good. Fine. So, we are okay with this. Now, similarly, let us see what happens in insertion sort. Remember, I told this is about total swapping. See, the time complexity, one will be for the iterations, one for loop will go from 1 to n for the iterations, or maybe n minus 1, but it is average case will be O of n only. Similarly, one for loop will be for the swapping. So, in that case, this will also go O of n only. So, ultimately the total time complexity is n cross n, that is O of n square. That is how it is working. Time complexity is same here as well, but the logic, how the algo works, you need to understand now. Fine, let us see that. And those who have come now, if you have not subscribed, same thing, please subscribe, please motivate me to create more content for you. Okay. So, let us try to understand this. Insertion sort, try to understand, very important. We will not take the first element because there is nothing previous to it. Think like this for the time being. Okay. We will consider this as sorted and this part of the array as unsorted. Okay. Fine. Now, what I do? So, that means our I will start from 1 to the length, the last element, that means, and j will start from, j will be here, will be equal to I minus 1, the previous index. So, let me write down the indexes also, 0, 1, 2, 3, 4 and 5. Okay. Now, try to understand this. Now, what is happening? I will check if this element is greater than this element. I will not swap, I will shift. How do I shift? Because this 5 is not at the correct position, this 2 needs to be here, right. So, how do I do it? Let me show you. Okay. So, let me remove this area, I will just remove this area and I will just show you what I am actually doing. I am trying to shift 5 this side. Fine. How will I do it? Simple as that. Let me remove all this and write it properly so that you can understand properly. Okay. So, let us remove this as well and let me draw the array again. So, this is the j value, this is j here, j is I minus 1, that is actually 0 in this case, I is 1. Okay. This is I here, I. Okay. Now, I am shifting 5 to the right hand side, this side. Okay. 5 came here, got it. Then came 1, 1 will be like this only, 0 will be like this only, 4 will be like this only, 8 will be like this only. Okay. Now, see what happens now. 2, we got a empty spot. How do you do it? Actually, because you can see you have copied back something like this. This is not correct. So, what you do? You have to store that variable. You have to store that variable. Which variable? I am talking about this variable 2 into some temporary variable. Say I am saying temp is equal to 2. I have stored it somewhere. Then otherwise I will lose track of that number, right? So, 5 shifted here, from here to here, it got here. So, I got a space. Now, this will come here because I have stored it somewhere. Similarly, now 2 is at the correct position. Do not worry about that. Now, come to 5 and 1. Okay. Now, j comes here, I comes here. See, 1 has to be shifted this side, but how many times? 1 is less than 5, even 1 is less than 2 also, correct. So, how do you write this? So, let me remove all this. Now, you have understood, right? Now see what will happen. I'll just write something like this. To move this 1 this side, this 2 and 5 have to be shifted to the right, correct? So it will look like this. To move 1 here, this 2 will come here, it will shift here, and 5 will shift here. Then only other numbers will be here, right? See, you don't know how many times you need to shift here. That's why the best looping statement will be a while loop here that we'll be using, because you can see 1 got shifted 2 times. Similarly, if you see now, this 0 will get shifted 3 times that side. Okay, that means I will have to write something like this now. Try to understand. This 1 got shifted here, this 2 got shifted here, 5 got shifted here, then only we got space for this 0. Make sense? That is how it is working. See, in this case selection, it was swapping. Here we are not swapping, we are shifting. We are shifting all the numbers to the right so that I can place 0 at the correct position. We are inserting 0, not selecting anything. We are inserting this 0 at its correct position by shifting all the other elements to the right hand side. Okay, is that clear? Now similarly it will be 4 and 8. Now after that, let me write it down here itself. Like this only I can write. Okay, one more time. One second guys. Fine, let's write here. You can see what will happen here. 0, 1, 2 is fine, 0, 1, 2 is fine. Now 5 and 4, obviously 4 will come here, 5 will go here, and 8 will go there, and these are all correct. Now I hope you have understood how insertion is happening. It is like playing a card game, right? And also maybe you have played this in your childhood. There was a game called Uno, where you used to sort the numbers. Unknowingly you have applied insertion sort only, and we are storing our currency notes also. We do something like this, say first 500 rupees, then 100 rupees. Okay, 1 second, let me select this, delete 500, then it is say 100, then we write 50, then 20, then 10. This is how we sort the numbers, right? Normally first 500, then 100, then 50, then 20, then 10, then 5, and so on. Same concept occurs here also. And the time complexity is how much? Because of the iterations we take one for loop, because of the shifting we take one for loop. So this goes for n and this goes for n. So the total time complexity is same, big O of n square only. That is how it works. I hope you have understood this now. Any doubts, feel free to comment them in the comment section. Yeah, Bobby says good evening. Good evening, Bobby. Okay, so hope you have understood this. Now selection sort, code, everything I have explained, I have written that. Let's do one thing, let's write down insertion sort now, okay, so that you can easily understand what I am saying. So based on this logic only, let's write down the code, okay. So I'll go to my editor, and here in my arrays I'll write down, say right click, new Java class, I'll say insertion sort. Fine, and we are not returning anything from the method, so public static void insertion sort. Fine, and we need the array from the user. And yes, I keep switching between languages, so sometimes I write the bracket after the array also, so you don't do this. Now first thing first, number of iterations. I said n minus 1 iterations. Why n minus 1? Because every time the array is having one element less, every time you can see 2, 5, they are sorted. Every time one element we will require less sorting. That's why n minus 1 iterations. Okay. Yeah, Bobby says understood. Thank you. Now let's write down the code. So what I am saying is, I will write the first for loop for the iterations. For if I say int I equal to 1, I will have to go till less than length. Okay, I will write I less than arr dot length 1 to n minus 1. Okay, I plus plus n minus 1 iterations. So, here I will just write down like this, n minus 1 iterations, fine. So, after that what were we doing? We were storing the variable into a temporary value. So, int temp is equal to ARR of I. So, ultimately I am storing 2 first, then j will be I minus 1, as I said, j will be here on the left hand side. So, int j is equal to I minus 1. So, we are shifting to the left hand side. What is the maximum limit till we can go? We can either move this number till here, at maximum till 0th index, not beyond that. So, my j value should be greater than equal to 0, not more than that, okay, not less than that. I mean to say there cannot be any negative index, correct. So, while j is greater than equal to 0, and the next option is this element should be greater than this element. That means ARR of j should be greater than this value, temporary value that we are calculating, okay. ARR of j should be greater than the temporary value that you have taken. As long as it is true, we will keep on shifting the value, right. How do you shift? See what we are doing, j equal to j plus 1. See, 5 came here, 5 was j, 5 came here, j equal to j plus 1, simple as that. That means I will have to write something like this, 1 second, ARR of j plus 1 is equal to ARR of j. I hope you have understood this. Why? Because this was j, this is j plus 1, this index, ARR of j plus 1 is equal to that value, okay. And how do I get this box, this empty box? I need to empty this because I want to store this here, right. J minus minus, I will decrement the j this side, j minus minus, okay. So, how do I write that? J minus minus, fine, makes sense. We did this so that we can get an empty space, and in that empty space I will simply add that temporary variable. See, once we did this, remember, once we got the space, in that space only 2 came here, okay. Now remember, j was here, j is 0, 0th index. When I do j minus minus, j has become what? Minus 1. Remember, j was 0, when I do minus minus it becomes minus 1. So, minus 1 is not the correct index to store the value. Where should I store temporary 2? It should be here, right. So, see what I am writing right now. After the loop is done, I will just write ARR of j plus 1 is equal to that temporary value. Hope you have understood this. This is very simple because j goes out. So, I need to come here at index 0. So, I am writing ARR of j plus 1, that is index 0 equal to temp. Similarly, for all the other iterations this will work out, and this is your insertion sort, as simple as that. Hope you have understood this. Now, let us validate this by calling from the main method, okay. This is my method. Now, I will go to the main, and first of all let me just write down, this is n minus 1 iterations, and this is what? This was the shift operation, and OPERATION, and last one, this is fill the empty space with the space, you can say, or empty space, you can say, index with the what we can say, with the temporary variable, temporary value, okay. Fill the empty space with the temporary value, that is what we are doing, okay. And now, from the main method I will create the array ARR is equal to, let us take the same array 5 2 1 0 4 8. So, 5 comma 2 comma 1 comma 0 comma 4 comma 8, okay. Now, what I will do is I will just say call the insertion sort method, pass the array, and then directly in one line I will print it. So, arrays dot to string, pass the array, fine. This is what I am doing. Let us see if it is sorted or not. Let us run this and check. You can see here, guys, 0 1 2 4 5 8, it is sorted automatically, fine. I hope you have understood this. Any doubts? Go through the code, go through the logic, go through the video again, try to understand. Okay. Hope you have learnt something. So please remember, again, if it is asked in the interview, just remember this: selection sort happens with swap. At each index that we select, we will have to place the least value. Okay. Insertion sort, we shift. Okay. We take the present element. See, for example, we take this 0 element, we have to shift it to the left hand side. Sorry, we take the present element. If it is less than the previous element, I will shift the previous element to the right, so that I can place that here. Okay. Shift, 1 shifted, 5 shifted, 2 shifted. See, 1, 5, 2 shifted, then only 0 will come here. 1 shifted here, 2 shifted here, 5 shifted here, so 0 comes here. Shift operation. Time complexity, ditto, same in both the cases, it is O of n square, O of n square. Hope you have understood that. Okay. Now I have no comments, so I will think that everything is clear. All have understood. Okay. Now guys, let's move to one very important algo. We have learnt merge sort. I have given you all the idea about that. Now let's talk about quick sort algorithm. Very important algo. Okay. Now, and also I will discuss the differences between both of them also. Fine. So let's try to understand that. I will just give you the intuition. Other things you will understand by the code itself. Okay. Very simple, very easy to understand. But just remember, sometimes they might be asking you one thing. This algorithm is called a in place sorting algorithm. Sorting, I am writing 2 times. Fine. So what happens here? There is a very simple concept of finding a element called the pivot. Based on the pivot, the concept is very simple. Try to understand. Okay. Imagine I have numbers like this: 9, 7, 2, 6, 4, 3 and 0. Any random numbers I have taken. Okay. And imagine I have a number, reference number. Say, what will I take? I will take 5. Okay. It has no relation to what I am teaching right now, but I just want to give you the idea of what is a pivot. Okay. Try to understand. I have, say, suppose a number 5 as the pivot. What is the real intention behind taking 5 as a pivot, or any number as a pivot? So pivot says that any number that is smaller than the pivot has to be on the left. Normal common sense. Okay. Any number that is smaller than 5 will come on this side, because we are doing ascending order, right? So that means, which are the numbers smaller than 5? Let's see here. 2. I will write 2 here. Doesn't matter if it is sorted or not. I will just write it out. 2. Then I have 4. Okay. Comma 4. Then I have 3. Comma. Then I have 0. These are all the numbers. They are less than the pivot. So obviously they will be on the left of pivot. Similarly, 5, the numbers which are greater than 5, let me write down the numbers. 9 is there, 7 is there, 6 is there. These are greater than pivot. Okay. See, these are less than pivot. N, the number. These are n greater than pivot. So they will always be on the right hand side. That is the simple intuition behind quicksort algorithm. We find a pivot element so that we can place all the numbers less than the pivot to the left and all the numbers greater than the pivot to the right. That's the basic idea about pivot. Okay, got it? And this reasoning is used in quicksort algorithm. Hope you have understood this. Now let's do one thing. Any comments? Not yet. I understood, sir, but where is insertion sort and selection sort used for real life applications? Is it still being used, or is it just useful for, yeah, Very good question, Bobby. It is used for interview purposes only for the time being. Normally, you will not be using this kind. Normally, in the industry, you will be either using merge sort or quick sort. Okay. So these are very stable and will be fast also. They are used. Insertion and selection are very slow. They are used for smaller data sets and we are not recommended to be used in the industry. But still for placement drives, for recruitment drives, for your interviews, it is very important. That's why, see, I am telling you one simple funda. DSA is required to get into the interview and get into your career. After that, not all the ways, all the times you will be using this, but it will help you to build a strong logic and your writing of code will be more efficient. That is why it is given, because technically speaking, to understand the algo, to do a dry run, to understand and traverse the array, do the iterations is difficult. That's why that helps you to build your intuition and your idea. That is why it is important. And nowadays most of the times merge sort and quick sort are very important, and I have also talked about radic sort and quick sort. Those are very important. Please go through them also, and anyways you have to learn all of them for your placement purposes, and mostly you will not be using that in the IT sector, but still it is good to know them. Okay, because you don't have any other choice, they will be asked to you in the interview. That's why. Okay, so as I said, we will find the pivot so that all the elements lesser than the pivot go to the left, all the elements greater than the pivot go to the right. Got it? Make sense? It's as simple as that. So let's take the array here. Now I'll take an array. Random values, okay? I'm taking say 6, 2, 0, 1, and then I have 9, and then I have 5. For example, random numbers you can take. Now, how to consider which number will be the pivot? To keep it very simple, what we will do is, I will say that let our, okay, let's do indexing first. I will take this as S and this is E, start and the end values. Let's write down the indexes also. This is, let's take a different color. This becomes 0, 1, 2, 3, 4 and 5. Okay, now I am saying ARR of start is equal to pivot. So I have by default said that let's take the first element to be the pivot. No need to do any other calculations. Just take the first element as the pivot. Now we need to place the pivot at the correct position, right? How will you do this? So I will find all the elements that are smaller than the pivot. Okay, in this case I will take a variable count is equal to 0. I will count all the values those are less than the pivot. Pivot is 6. Which are the elements less than 6? I will have 2 is there, then I have 0, then I have 1 and then I have 5. Make sense? And let's do one more thing. Let's add 1 or 2 more numbers, something like this. Okay, let it be like this, no problem. Otherwise you will become confused. Okay, if I change the array now, it's not recommended. So let's not do it. So 2015 are the numbers less than our pivot, which is 6. Okay, now I will say count is equal to how much? 4. So there are 4 elements which are less than the pivot. So now I will find a very important value which is called the pivot index. This is also sometimes called the partition index. Why? Because this index divides the array into such a way that all the lesser elements go this side, all the greater elements go this side. Okay. So pivot index is equal to S plus count. Understand? S is 0 only, plus count. How much? 4. Okay. So the pivot index is actually 4. Now I understood that 6 should be placed here. Got it? So what I will do? I will swap the ARR of start and the ARR of pivot index. These two values I will swap. Okay. Now see what I am doing. Try to understand. So 4, right? So what I will do is this 9 will come here, doesn't matter whatever value is there, okay, don't worry about that. 9 comes here and 6 comes here, fine. That is the correct position, because if you understand and analyze here, if I say 0 is coming, 1 is coming, 2 is coming, 5 is coming, so technically 6 should come here only, right? Did you understand? That's why I have found the correct position where to place 6, the pivot. Make sense? Okay, got it. Any doubts? Let me know, no problem at all. Now we have to manage both the sides. Anything greater than pivot will go to this side, anything less than pivot will go to the other side. For that we can take two variables. So let's do it here, okay. So I'll just erase this part, okay. This part I will erase. Anything, any comments? No, not yet. So everything is fine. Let me just refresh this to check if anyone has made any comment. No, it's all okay. For the timing, it's fine. Okay, not yet. Fine. So as I said, I will have to manage the values. So try to understand. Okay, I'll write the same array here so that we can figure out what to do. We have placed the pivot at the correct place. How many elements? 1, 2, 3, 4, 5, 6. So this is 9, 2, 0, 1, 6 and 5. Okay, so this is my pivot and this index is called the pivot index. Okay, now what I am doing is I am taking a variable I here which is at the start index, and I am taking j here which is at the end index. Okay, so I will write something like this. While my I is less than pi, pi stands for pivot index, and my j is greater than pivot index, because j will come from this side, what I will do? I will simply check like this. If my this value is less than pivot, here this is the pivot, okay. If anywhere here the values are less, all good. If they are not less, it is not good, absolutely not good. So I will just say if our ARR of I is less than pivot, very good, I don't have to do anything. I can increment I plus plus. Okay, I can do it in a while loop also. Similarly, if our ARR of j is greater than the pivot, all good. Whatever numbers are greater than this, all good, no problem. I can say j minus minus. I have to go this side. From I am reaching this side, from j I am reaching this side, so that I can interchange. Now try to understand, okay. See the first condition, ARR of I less than pivot. ARR of I is 9, 9 is not less than pivot. So this I plus plus will not happen, it will not increment. But in the other case, try to understand, ARR of j is greater than pivot. What? 5 is not greater than pivot, 5 is less than pivot. So here also j minus minus will not happen. We will have to interchange them, then only it will be managed. So how do you do it? Very simple. Just write a swap, temp equal to a equal to b, b equal to temp. That swapping will happen something like this. See, so this 9 will be swapped with this. This will become 5 and this will become 9. So we interchange, got it? And now I will move here. I moves here and j has already been here, no problem at all. After that, if you see, 2 is less than pivot, 0 is less than pivot, 1 is less than pivot. I goes here, I goes here. J is already here, so it will not move back. Okay, because we have written what? J greater than pivot index. Okay, so this actually manages the values very well. If you see, all the values on the left side on the pivot are smaller than the pivot, 5201. All the values on the right side of the pivot are greater than the pivot. Now what next? How will you sort the other part? This part and that part. Very simple. What is that? Recursion. Okay, हमें नहीं करना है, everything else recursion will do. Okay, that is why recursion will again find the pivot in this part, and it will automatically keep on sorting that. I hope now you have understood the intuition and the algo also. Any doubts, ping them in the comment section. Okay, now we can easily go and write the code now. Okay, let's do it. If you want, you can take a screenshot also. So insertion was done. So now let's write down the quicksort algo. So here I'll just right click and create a new Java class called quicksort. Okay, and fine. First we need to find the partition index, right? So okay, what I'll do is int, let's write static as well. I don't want to create an object. Static int partition index. I need the array, I need the start value, and I need the end value. Okay, this two I need. Fine. And let's see if anyone has, yeah, Bobby says understood, all good. Thank you, Bobby. Anybody has said anything else? I don't think anything else has been written. Okay, all good, no problem. So let's start writing the code. So first thing first, as I said, I will take the pivot. What did you say? We said that we will take the pivot as the ARR of start value. Then I will check where I can place this by doing what I said. I will place it at its correct position by checking how many elements are smaller than the pivot, right? So let's do it now. Int count is equal to 0. Okay, now I'll just say for the first element is already taken, I will take from the next elements. Okay, because 6 was already taken here, 6 was already taken. So I am trying to check here in this part 2015 all the other values. Okay, so let's try to understand that. For int I is equal to 1, let me just increase the size a bit. Okay, I equal to 1, I less than, I have to go till the last index, right? See here, see the diagram, you will understand. From here till end I will go. I less than equal to end I have to write. I plus plus. So I will just say if any element ARR of I is less than our pivot value that we have taken, we will simply do count plus plus. Correct? Got it? After this we have got the count. Now what should we do? We have to place the pivot at the correct position. Okay, place the pivot at the correct position, or what we can also say index. Obviously it is an index because we are returning the partition index, right? Now what will you write? Simple as that. I'll say int pivot index is equal to start plus count. Start was 0 in our case, 0 plus count gave us the 4th index. Got it? Now after that, what was the next step? Now I need to swap them. Correct? I need to swap this value and this value. We have done that. So for that, let's write down a simple method to swap them. Okay. So before this, I'll just write static int. It does not need to be int, void swap, and I need the array, and I need the I value, and I need the j value. These I and j are indexes. Okay. So I'll just say int temp equal to ARR of I, ARR of I is equal to ARR of j, ARR of j is equal to temp. Okay, I and j being the indexes of the array which will be passed to this. Okay, now simple as that. I need to swap here, right? I need to call this method here. So how do I call here? Swap, array will be given, then I will need to pass the indexes. What were the indexes? You have to tell me. The indexes are the pivot index, because this is my pivot index, this one like this, and this value, the start, comma start. You can write any one anywhere, it does not matter. S comma pivot index is also fine. Okay, make sense? Any doubts, please ping me. I think not yet, nobody has given me any comments, so I think all fine. Okay, great. So let's go ahead and write down the other part. Now after this, what do you do? We have, as I said, now I have placed it here. Now what was the next step? We have to manage this. The left part of the pivot will be all the smaller elements, the right part of the pivot will be all the greater elements. How are you doing it? By taking I and j pointers. I was at start, j was at end. Okay, so write down this thing now. I'll write the comment. Let's manage the left and right parts of the pivot. Okay, so as I said, I will be equal to start, int j will be equal to end. Okay, so as I said, the while loop will be if our I is less than pivot index and our j is greater than pivot index, till then only we will be doing it. Okay, how will you do it? I will have to check something like this. While my all the left hand side values are less than the pivot, it is very good, no problem. Then I will just say I plus plus. Let's move. Normally I will move this side, and same thing j minus minus. I will write like this. While my ARR of j is greater than the pivot, it's very good, no problem. Not pivot index, okay, pivot, the value. In that case, what will I do? Let me just scroll it a little bit up. Okay, ARR of j is greater than pivot, j minus minus, all good, because all the values to the left of, sorry, right of pivot should be greater, it's fine. But still, if it does not work, then what will I need to check? Can you tell me, anybody? If still my I value is waiting at that part and the j value is waiting at that part without getting incremented, see here it happened. This 5 was what? Not 5, we had something else, right? 9 we had here and 5 we had here, then we had swapped them, right? So I will write something like this. If my I is still less than pivot index and my j is still greater than pivot index, that means I need to do a swap of these elements, I and the j elements. So already I have the swap method, so I'll call them, I'll pass the array, I'll say comma I value and the j value, these are the indexes. Make sense? I hope this is clear now. Got it? And this method is not done yet. This method is actually returning you one index. See, static int, it is returning an index. Based on that index only, we will do the quick sort. Okay. So this is just our helper function. The partition index method or the function is actually just to find out the index from which the sorting will occur, start. Okay. So here after this while loop, see, this is the while loop. I will go back here. Yes. After this, I will just say return the pivot index. I hope this is clear now. So this is the whole prototype of your partition index method. This will help you to find the partition index, and this will be called recursively again and again. So for that, let's write down the quick sort method now. So public static void quick sort. Similarly, here also I will need the array, I need the start, I will need the end. This start and end I will pass from the main method later. Okay. So as I said, very important, try to remember this, the base case. Base cases or the kernel cases has to be considered before only. Any comments? I think not yet. Let's check once again, because I need to keep checking actually. So I am just checking if anyone has said anything. Not yet, so fine. What will be the base case? Imagine there is one element only. In that case, the start and the end will be coinciding together at one point. Then I don't need to sort, there is only one element. So I will just say if my start is either greater than or equal to the end. There is only one element, don't do anything, just return. Make sense? Only return, not do anything. Otherwise we have to find the pivot for the partition, partition. Okay, so let's drag it up. So the base case is when there is only one element, don't do any sorting, just return from the function. Okay, otherwise how to find the partition index? We have a method for this. This is the method. So I'll just say int p is equal to, call the partition index method, pass your array and pass the start, pass the end. Okay, that's all. This start and end we are having it here. From that we are passing it here. Okay, now based on that, as I said, this part is not sorted yet. This part is sorted. It's okay. This part is not sorted. I have to do recursion so that I can get this area sorted. It will be broken down into pieces by finding the pivot. Okay, 5 will be the pivot, 5 will be placed this side, and so on. It will keep on going like that. Okay, so now I just right now use recursion to sort the two halves. Okay, so for the left part, just remember pivot is at the correct position. I don't need to sort this. I need to sort from here till here and here till here. So how will I write? Let me check the pen. Yeah, it is here. So try to understand. Okay, for this the last thing that you have to remember is I don't need to sort this. This is my pivot. So I need to sort from start to p minus 1. Got it? Because this is the p index. I don't need to sort till here. This is p index, p. And from this side, I need to sort from p plus 1 till the end. Did you understand what I am saying? Once you found the pivot, this is the pivot index. So I need to sort from here till here. Start till p minus 1, because p is this. Similarly, from this side it will be p plus 1 till end, because there can be more elements also. Got it? That is how it is working. So let's write down the code now. Left part will be, call the quick sort algo, same thing, pass the array start comma p minus 1, the left hand side. Similarly, I'll call the quick sort algo, sort the array from p plus 1 till the end of the array. That's all. Make sense? This is how the quick sort algorithm works. Now let's go to our main method and just call this and see whether it is working or not. And you can see there is a recursive call here. Okay, this is the recursive call. That is why it is showing like this. Fine. Now main method, I'll simply write down the same array. Let's take the same array only. What is that? 520169. Okay, or 920165. This one was, which one was that? Anything is fine. Int arr, sorry, is equal to 520169. And if you want, you can add random values also. Any other values you want, you can take it. So now I will call the quick sort method, pass the array, and I need to pass the start and the end position. My start position is 0, my end position is, let me write down a variable to make it easy. Int n is equal to arr dot length. Okay, n is the length. Now it will be 0 to n minus 1, right? N minus 1. This is start, this is end. Now after that, I'll just print the array s out, arrays dot toString, pass the array. Let's see if it is working or not. Let's validate. Okay, we're getting an exception. 7 length. Where is that? Okay, let's see the line number. Okay, we're getting some error somewhere. Which is that line? Error 5, I equal to j, j equal to temp. Something is wrong here, I guess. Where did you do the mistake? I equal to s, j equal to e. Can anybody find this? I less than pivot index, j greater than pivot index. Anywhere Let me just check where is the index 7 out of bounds for length 6. Where is that happening? 721. Okay, let's correctly check that from the beginning so that you can see this. Okay, I think it is happening in the swap function only. Let's check once. Ij, it's fine. I equal to j equal to 10, that is also fine, all good. Now pivot is 0, count I equal to 1 less than equal to I plus plus, this is fine. Okay, yes, yes guys, see this is the point that we have not considered properly. I said I will, this was array of S was the pivot, right? Gradually we are using recursion, so ultimately I have written a very bad thing. I have written 1, it is not 1. After S, this index is S plus 1. This S can be anything, right? When you are using recursion, this S can be 0 index, index number 4 or something. So here writing 1 will not work out. So I think this is the case where it is not working. This should be S plus 1. Now let's run this and check what is happening. Yep, you can see 0 1 2 5 6 9. Now it worked. Okay, and it is very important to debug your code also, otherwise you will not be able to understand what went wrong. So this was the mistake. Okay, so it is good that we rectified it here only, because in the interview if you make this kind of mistakes it might be difficult for you. Okay, so I hope you have understood this. So as I said, it is S plus 1. This S will change, right? When we break down the array, this S might change. It might not be 0, it can be different also. That's based on that. If I write 1, this 1 will not be constant every time. That's why it was changing. So I wrote S plus 1. And nobody told me to share the code. Nobody has told me till now that you need all the codes or nothing. So that's why I am also taking it carelessly only, and I am just finishing off the topics, and I have the code. Anybody needs them, you just have to tell me, then I will definitely come up with the codes. And as I said, if you want a demo on how to use Git and GitHub to push all the codes to GitHub and send it to you, also I am ready to do it. You tell me, tomorrow only I will do it, but I need motivation. You guys have to tell me that you need it. Okay, now I think there are no comments at all, so all good. I think for the time being everything is fine, everyone has understood. Okay, so guys, one thing that I want to tell now is practice, practice, practice. That is the only way you can crack interviews. Okay, otherwise it is difficult. Right now, only thing that will get you a job is skills. Without skills you are nothing. Even I am nothing. Anybody will be nothing if you don't have skills. So make sure you learn the concepts properly, practice the code, try writing the code, then only it will be easy for you to understand them. Otherwise, if you just go through the code and you think that okay, I will be able to solve it directly in the interview, it is not possible. Write down the code, write down everything one by one, see the errors, try to debug the errors. That is how you learn. Okay, at least half an hour every day is mandatory for you, those who are actually aspiring to become a developer and trying to get into the IT industry. It's very, very important. Okay, so I hope you have liked this. If you have any doubts, please ping them in the comment section. I'll be very happy to clarify all your doubts, and thank you for those who are watching, for those who are supporting me in my journey, and I'm doing this for you guys only. And yes, it is a win-win situation for everyone. So stay tuned, be with us, and thank you for watching. Till the next time, this is Saurabh signing off. Bye bye and happy learning. Thank you guys. Bye.